Elon Musk just revealed first nuclear fusion reactor powered by AI. A major, eyebrow-raising breakthrough in science. Nuclear fusion, which used to be quite an unachievable project for years, has become possible. All thanks to the genius entrepreneur, Elon Musk. He disclosed an unprecedented reactor powered by artificial intelligence, AI, to carry out the fusion successfully. But how would this science fiction happen in real life? What's the secret? Hello, and welcome to Elon Musk Evolution. If you're a Musk fan and don't want to miss anything about this incredible person, then smack the subscribe button and hit the bell icon so that you will be notified whenever a new video is uploaded. In today's video, we're going to talk about the first nuclear fusion reactor powered by AI, which is revealed by none other than multi-billionaire genius Elon Musk. The interior of a tokamak nuclear reactor, a donut-shaped tank meant to confine a nuclear fusion event, is filled with a unique form of pandemonium. Finding smart ways to control and confine the plasma will be key to unlocking the potential of nuclear fusion, which has been mooted as the clean energy source of the future for decades, noted Elon Musk. Hydrogen atoms are smashed together at unfathomably high temperatures, creating a whirling and rolling plasma that is hotter than the surface of the sun. The science behind fusion appears to be sound at this time, so there's still a technical problem to solve. We need to be able to heat and hold this substance together long enough to extract energy from it. That's where Elon Musk kicks in the picture. He's been working on a cooperative research effort with the Swiss Plasma Center to create artificial intelligence for directing nuclear fusion reactions in stars that are also driven by fusion. Fusion reactions occur when the nuclear force drawing two or more atomic nuclei together overcomes the electrostatic force pushing them apart, fusing them into heavier nuclei. The process is endothermic for nuclei heavier than iron 56, necessitating an energy input. The heavier nuclei, which have many more protons than iron, have a stronger repulsive force. The process is exothermic for nuclei lighter than iron 56, releasing energy when they fuse. Because hydrogen has just one proton in its nucleus, it needs the least amount of work to fuse and produces the highest net energy. According to Musk, hydrogen is also the easiest fuel to fully ionize because it only contains one electron. The strong force works only over short distances, up to 1 femtometer, or 1 proton or neutron's diameter, but the repulsive electrostatic force between nuclei acts over greater distances. The fuel atoms must be supplied with enough kinetic energy to approach each other closely enough for the strong force to overcome the electrostatic repulsion to initiate fusion. The Coulomb barrier is the amount of kinetic energy required to get the fuel atoms close enough together. This energy may be obtained by either speeding up atoms in a particle accelerator or heating them to extremely high temperatures. The electrons in an atom are taken away when it is heated over its ionization energy, leaving just the nucleus. Ionization is the name for this process, and an ion is a nucleus that results. As Musk explained, plasma is a heated cloud of ions and free electrons that were previously bound to them. Plasmas are electrically conductive and magnetically tunable because the charges are separated. This is used in many fusion devices to confine the particles while they are heated. The mere gravitational mass of hydrogen atoms is enough to bind them together, and they triumph against their foes. Instead, scientists on Earth employ huge magnetic coils to contain the nuclear fusion process, coaxing it into place and sculpting it like a potter molding clay on a wheel. To keep the plasma from reaching the vessel's sides, the coils must be carefully managed. This can damage the walls and cause the fusion reaction to stall down. The fusion process can't persist without magnetic confinement. Thus, there's minimal chance of explosion. However, Elon Musk wants to tweak the plasma's arrangement and test out other forms to see if they can get more power or a cleaner plasma. It entails a significant amount of engineering and design effort. Traditional systems are computer-controlled and based on models and meticulous simulations, but they are complicated and not always optimal. Elon Musk has created an artificial intelligence capable of controlling plasma on its own. Researchers from the two organizations trained a deep reinforcement learning system to regulate the 19 magnetic coils inside TCB, according to Elon Musk. The configuration of variables, the Plasma Center has a tokamak that is used to conduct research that will help construct larger fusion reactors in the future. According to Tesla CEO Elon Musk, artificial intelligence, namely reinforcement learning, is particularly well adapted to the difficult issues presented by managing plasma in a tokamak. A neural network is a sort of setup that was first trained in a simulation to replicate the architecture of the human brain. It all began with monitoring how different settings on each of the 19 coils influenced the form of the plasma inside the vessel. It was then given several forms to try to reproduce in plasma. A D-shaped cross-section was incorporated, which is similar to what would be utilized within either. Previously, the International Thermonuclear Experimental Reactor, a large-scale experimental tokamak now under construction in France, with a snowflake design that should help distribute the reaction's high heat more uniformly across the vessel. Both in the simulation and when the scientists did the identical tests for real inside the TCB tokamak to confirm a simulation, Elon Musk's artificial intelligence was able to independently figure out how to construct these forms by properly manipulating the magnetic coils. It's a huge step forward, one that might influence future tokamak design, or perhaps hasten the development of functional fusion reactors, stated Musk, according to Yasmin Andrew, a fusion specialist at Imperial College London. It's an encouraging result. It will be fascinating to see whether the technique can be applied to a bigger tokamak. Elon Musk had a unique problem when it came to fusion, since the process is both difficult and continuous. The reactors themselves might be reconfigured to take advantage of AI reinforcement learning's tighter control. The endeavor might allow researchers to push the boundaries and speed the lengthy road toward fusion power, Musk argues in the end, because we can take chances with this sort of control system. AI would allow us to explore things we wouldn't otherwise be able to. We wouldn't risk it if we didn't have to. If we are confident that we have a control system capable of pushing us to the edge, but not to the point of exhaustion, we can genuinely investigate alternatives that would otherwise be unavailable. Fusion power promised to offer more energy per unit of fuel than any other contemporary fuel-consuming energy source. The fuel, which is predominantly deuterium, is plentiful in the ocean. Deuterium makes up roughly 1 in every 6,500 hydrogen atoms in saltwater. Seawater is abundant and easy to acquire, meaning that fusion might satisfy the world's energy needs for millions of years. As per Musk, the deuterium-tritium fuel cycle is intended to be used in first-generation fusion facilities. This will need the usage of lithium in the tritium breeding process. It's unclear how long global lithium supplies will be sufficient to meet this need, as well as the demands of the battery and metallurgical sectors. Second-generation plants are anticipated to progress to the more difficult deuterium-deuterium process. Although the deuterium-helium-3 interaction is intriguing, the light helium isotope is almost non-existent on Earth. It's predicted to be prevalent in the atmospheres of gas-giant planets and exists in usable levels in the lunar regolith. According to Elon Musk, fusion energy might be utilized for deep space propulsion within the solar system, as well as interstellar space travel when solar energy is unavailable, such as via antimatter fusion hybrid engines. Okay, folks, that's it for today's video. If you're interested in watching more videos on Elon Musk, then what are you waiting for? Simply click the subscribe button and ring the bell icon because new videos are on the way.